white kid, but I'm still bicycling and recycling.
On gas laws, we have four main laws: Charles' law, Boyle's law, Gay-Lussac's law, and Avogadro's law. The first law is Charles' law. This law relates volume and temperature and says that these two are directly proportional, so as one increases, the other one will increase as well. The constant for this law is V divided by T equals a constant, and we can get formulas like V1 divided by T1 equals V2 divided by T2. The graph shown shows how as volume increases, temperature increases as well. Also, since everything is made out of particles, their size increases as temperature rises, causing a larger volume, meaning that they take up more space in a recipient. And you can notice this when you have an inflated football and you take it out on a winter day, and you can notice it shrinks slightly. Next, we have Boyle's law. This law relates volume and pressure, and it says that they are inversely proportional. So as volume increases, pressure will decrease. The constant for this is P times V equals a constant, and we can get formulas like P1 times V1 equals P2 times V2. Boyle's law says that by decreasing the volume, particles are pushed closer together, and they exert a greater pressure on the walls of the container. Also, pushing in a plunger of a plug-up syringe decreases the volume of the air trapped under the plunger, and it increases the pressure you put on it. Next, we have the Gay-Lussac's law. This law relates pressure and temperature, and it says that they are directly proportional, so as one increases, the other one will increase as well. The constant for this is P over T equals constant, and we can get the formula P1 over T1 equals P2 over T2. Also, when you increase the temperature, the particles move faster and in different directions, making it crash against the container, making the pressure increase. Also, an example of this can be when you travel to the beach or to a place where the temperature is hotter, since this will make that the tires of your car expand, making the pressure go up. Finally, we have the Avogadro's law. This law relates volume and the amount of particles in it. It says that as volume increases, the amount of particles in it increases as well, saying this is a directly proportion. The formula for this is volume over N equals constant, and it can be described with the formula V1 over N1 equals V2 over N2. If you increase the number of particles in a container, the volume increases since it has more particles in it. And perfect example of this is when lungs fill with air. As we breathe in, they are filled with air, and as we exhale, they decrease the number of particles, decreasing the volume as well. There are also other laws from the four gas laws that we already know. One of them is the combined gas law. This combines the Charles law, Boyle's law, and Gay-Lussac's law into one law. This uses the formula V1 times P1 over T1 equals V2 times P2 over T2. This is used when you need to explain the mechanics where it uses pressure, temperature, and volume, and these all of them are affected. We also have the ideal gas law. This is the equation of state of a hypothetical gas. It is a good approximation to the behavior of many gases under many conditions. This happens when P times V equals N times R times T, where P is the absolute pressure of the gas, V is the volume of the gas, N is the amount of substance of gas, R is the ideal gas constant, and T is the absolute temperature of the gas. Next, we have Graham's law. This is the rates of effusion of gases at the same temperature and pressure are inversely proportional to the square roots of their molar masses. Their formula is Rate of effusion of gas 1 over rate of effusion of gas 2 equals square root of m2 over m1. Or it can be expressed also as v1 over v2 equals m2 over m1 square root. Also, we can see in this graph that each gas has a different rate of effusion than the other one.
In our experiment, we chose Charles' law. Charles' law consists on a direct relationship between temperature and volume. Our experiment consists on proving this law. We heated and cooled a balloon to see how volume reacted. In other words, we changed the temperature to see how it changed. We measured the balloon circumference and saw how volume changed. When we cooled the temperature, we decreased temperature, the volume decreased. When we increased temperature, the volume increased. It was very good, and my biggest conclusion is that it is true. We measured two balloons. The small one had more precision. The biggest percentage of error for this balloon was about 5%, and for the biggest one was about 16%. We found that it is very credible, the experiment, and our conclusions are very